Today I will present Helmholtz Carousel. First, the problem is attach Christmas tree balls on a low friction mounting or carousel such that the hole in each ball point in the tangential directions. If you expose this agreement to the sounds of the suitable frequencies and intensities, the carousel starts to rotate. Explain the phenomenon and investigate the parameter that results in the maximum rotation speed of the carousels. Overview what happened. If you expose this agreement to the sound of a suitable frequencies and intensity, the carousel starts to rotate. For a theory, I use simple harmonic motions. An experiment change the sound intensity and measure the maximum velocities. Conclusions explain the phenomenon and investigate the parameter that result in the maximum rotation speed of the carousels. So what's happened? Let's look at the videos. You will see when I play the sounds, that is the same frequency with the bottle, then the bottle will rotate. What is the origin of this phenomenon? Sounds that have the same frequency with the bottle and the air from inside bottle will flow out of the bottle. So for the theory, the vibrations is due to the springiness of air. When you compress it, its pressure will increase and it tends to expand back to its original volume. It can thus vibrate like a mass on the spring. Assuming the Helmholtz resonator is a mass spring system, the fundamental resonance frequency is given by frequency equal 1 divided by 2 pi square root k divided by m, where f is the frequencies and k is the spring constant of the air in the cavity and m is the mass of the air in the neck. So the spring constant in the air in the cavity is k equal rho 0 c square a square divided by volumes, where rho 0 is the air density and c is the sound speed of the sound. The mass of the air in the neck is m equal rho 0 L palm A, where A is the cross-sectional area of the neck and L palm is the real length of the neck. We can find approximately frequency of the bottle from f equals c divided by 2 pi square root a divided by the volume multiplied by L palm, where f is the bottle frequency and c is the speed of the sound and a is the cross-sectional area with the volume of the bottle and L palm is the real length of the neck. L palm equal L plus 0.8 square root a. Or we can find approximately by blowing the bottle neck until it vibrates, then use the frequency meter to measure it. So when we open the sound that have the same frequencies with the bottle, then the bottle will vibrate and the air from inside the bottle will flow out of the bottle. From the Newton's third law, action equal reactions, the force that the air come out of the bottle equal the force that push the bottle. That is why the carousel rotates. This is a picture. You will see when I play the sound, right? And then they will have a force from the air that flow out of the bottle. That is an action, and they will have a reaction force. There is a force that push the bottle. This is the video that show you that have the air flow out of the bottle. Again. First time, and then the air will flow out. For the experiment, propose to measure to measure the frequency of the carousels and sound intensity. Material I use the bottle, 1 liter and 600 milliliter. Trace speaker, 10 inches, and no balloon. Detect tool I use scale, weighing machine, high-speed camera, sound intensity meter, amplifier, and frequency generator. So I will use frequency generator to generate the bottle frequencies. 1 liter bottle equals 160.4 Hertz and 600 milliliter bottle equals 209.7 Hertz. And then I will use the amplifier to amplify the bottle frequencies to sounds for speakers. We use the sound intensity meter to measure the intensity of the sounds. Then use the tracker to measure the frequency of the carousels. This is the result of a bottle. You see when the sound intensity is increased, then the frequency of the carousels and the omega will be increased too. That means if the sound intensity is increased, then the speed of rotation of the carousel will increase too. This is a graph of omega and sound intensity. For the bottle 600 milliliter, when the sound intensity is increased, and then the frequency of the carousels and the omega will increase too. That's the same as a 1 liter bottle, and then the speed of the carousel will increase. This is a graph of sound intensity. This is a graph of a force that pushes the bottle and the sound intensity. For the conclusions, the reason that carousel rotate because when we play the sounds that have the same frequency with the bottle, then the bottle will vibrate and the air from inside the bottle will flow out of the bottle from the Newton's third law. Action equal reaction, the force that the air come out of the bottle equal the force that push the bottle. That is why the carousel is rotate. From the experiment, we will know relation between the sound intensity and the omega, like this, and we will know relation between sound intensity and the force that push the bottles. So if we want to increase the maximum rotation speed of the carousels or force that push the bottle, we have to increase sound intensity. This is my reference. Thank you for your attention.
Could I ask that, did you notice when the bottle is rotating?
Yes.
Does it rotate at the same velocity or?
No. If I increase.
No, it's when the sound intensity is the same.
Rotate. Yes, it should be the same if the volume of the bottle not change.
Why don't you think that when we give energy continuously, there's no an acceleration? Or?
I think I look for it and it's just the same. For the first time, I do an experiment and then I wait for about 5 minutes or 7 minutes. And then I take a picture and then
could you
measure.
Go to the theory slide?
Okay. This.
The next one. Next. Back. back and back again. Okay. How do you use this theory to apply with your conclusion or your experiment?
I just show you that if you want to calculate the approximately frequency of the bottle, then you can use this theory to calculate. But if you want to do another way, you can do the real experiment and then measure it.
So, okay. And when you find I will ask you about the experimental step, and you use the formula to calculate the natural frequency of the bottle.
I use, but it has some errors, and then I think I will use the real experiment to calculate.
The real experiment.
Yes, like blowing the bottle and then use a frequency meter.
When you calculate the frequency by this step, and did you fix the temperature around the environment?
The temperature did not change because I tested at the same time.
Same time while you do the experiment, you record the frequency and turn the volume up, and at that time,
Do frequency at the time. I think the temperature of the room did not change, and then there is not the effect if the temperature change.
so okay, could you see the graph at the 600 millimeter bottle?
600 bar
See the graph?
graph. Graph of what?
This graph. Back and okay. Did you see that that point and that point they are so like a far distance from this? Is when we change it a little bit, it come higher. So how do you explain it by? How can you explain it possibly?
If I increase the sound intensity and then the velocity will increase to
Isn't it up at a constant rate? Constant rate.
constant
Rate.
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 Rate. Yes. You look like this. This is the table, and then the sound intensity is not like the power of 2 or something. But
Yes. But could you go back to the graph again? Yes, we will see that the distance from that point to that point is the same from this to this and this to this.
not the same.
How far is it?
Because when we do the experiment, my meter can't do the same.
And please go to the conclusion, please. How do you explain your conclusion that what theory that you use to explain the conclusion that that's direct property to the angular velocity?
From the result of the experiment.
Yes, but
You look
what?
by the graph. It is increase. When you increase the sound intensity, and then the frequency and the force of the carousel is increased too.
And what theory that you use to support your experiment?
Support
What theory that you use to support the conclusion of your experiment?
the conclusions. I use the third law of Newton.
Yes, this is to support to explain that y is rotating, and the conclusion that I is direct property to the omega. Why does it like that? There you have do you have a conclusion to?
The first part is as explained that why the carousel is rotate, right? And then the second part from the experiment and down is find the parameter that make the carousels rotate at the maximum in the maximum speed. So this is found by the experiment.
Do you know that why it's like that?
Because I do the experiments. Because if I know the equation before I do the experiment, then why should I do the experiment? Because I know already.
You do the experiment and you have the result. And
Yes.
And how do you explain to me that's why it's just like this? Because do you think there's some theory to explain this?
Some field to explain this.
Your result.
Yes.
What's that?
The parameter just make the carousel to the maximum speed is the sound intensity.
Theory?
Not a theory.
Yes, but I asked you what there are any theory that we can use to explain this.
I did not looking for that because if I know the theory before do this experiment, why should I do this experiment?
So, okay. Could I ask you that what the way that you use to vary your parameter
Vary the parameter
in this experiment?
in the second experiment.
This experiment,
In the experiment.
like why you use the sound intensity in your experiment?
The first time I don't know anything, then I do the experiment and then I look at the carousels. I change the frequency, I change the intensity, and I see that if I change the intensity and then the speed of carousel will change. And if I increase the sound intensity and the speed of carousels will increase too.
Okay. Could you go to like a action and reaction or something? Okay. This slide. What's the action in this experiment?
Actions is the air that's come out of the bottle,
And what's the reaction?
the force that push the bottle,
The force that puts the bottle, the force of
the force of the air.
the air
push.
outside.
Yes, but I don't know what is the force of this, but I know that it have a force that push the bottle. It's just like the space rocket or something like that. It look
Like a what?
Like a rocket or space.
Like a rocket?
Yes, space shuttle.
You say that the action is the force that the air come out,
Yes,
and the reaction is the force that the
push the bottle.
water. And can we do this? Okay. So, okay, first, there are some points that I want to know that the result of him is he has no theory to support his result, and he told me that he just only to find the parameter that make the bottle rotate and in the maximum rotating speed, and the theory that he used to explain the phenomenon that is rotating is the Newton's third law, that the action, he told me, is the force that the air comes out, and the reaction is the force that the air pull the bottle to rotate. And that's it. Okay. Thank you.
First, I'll go with the reporter. The pros, I think the reporter explained the theories that support this experiment. And I think the video gave a clear observation of the Newton's theory of action equals reaction. And the reporter did say about the trends of finding the maximum omega and the frequencies. But the reporter did not use a Christmas ball as the problem statement. And the reporter did not say that the Christmas ball is equivalent to the bottle or not. Next is some of the slides. Some text are hard to see when with the slide. Example with this at the last column under the I and the F. So if we want to increase, I see that it's very hard to see. And the size of the characters are small. More than that is the table has too much data and it is too much to process for the viewers. And from the graph, I see there's no trend line at all. There's only points of the data. And you did not talk about the limit of the maximum speed, or it can just go like fast as a car or 60 miles. I don't know. Next, the opponent. The opponent said there's no theory supporting in this experiment. I disagree. And another from the reporter from the opponent asked the theories of the experiment. But the reporter said, if we have a theory and we will know the answer, there's no need to do the experiment, which I think we should compare the theory with our real experiment. So that's a good point of the opponent. Other is the opponent's question about each section of the presentation, the conclusion, experiment, theories, and other things. A good thing is the opponent question about the origins of the parameters that the reporter wants to study about, which I think could give a lot information. Next is the opponent question about the environment, which will affect the quality of the data that is that we get. Okay, thank you. That is all.
Okay, for this proportionality, for these two proportionalities, you say that I depends on omega and I depends on the force, right? And the reviewer, you said in your conclusion, you agree with him or not? That I is proportional to omega and F.
From his results, I agree.
How about the opponent?
No, I disagree that.
Why?
Because I think there are some maximum rate of the rotation that I direct proportional to the omega.
So do you agree that I is proportional to omega and I is proportional to F? Do you agree with that?
No.
So,
that would
okay,
be.
let I rephrase the question. Which one is the dependent variable and which one is independent variable?
Independent variable is
Which one cause which one? Which one is the cause and which one is the effect?
the cause is omega.
What causes what?
For this conclusion, the force is the cause It's like a
Okay, between these three, omega, F, and I, three of you answer me. Which one is the cause and which one is the effect?
The cause is the sound intensity and the effect is omega and force.
Reviewer?
The cause is the intensity, and the intensity causes the force, and the force causes the omega.
Okay. Opponent?
in real the cause is intensity that and the omega and omega is the causes.
So you can answer the first question now, right? And you know that you answer all wrong. Okay.
How does the air inside the bottle receive the energy from the speakers? Through the wall, or what is mechanism right there? I want to ask the opponent first.
It's like when we give the sound, the air around it will be like oscillating, and it's oscillating and oscillating, and the air inside will be by the bottle, and maybe by the it's like oscillate to the bottle and maybe come in into the bottle too.
So it's go right through the bottle, go to the air inside.
Yeah.
Okay. What do you think?
I think when the bottle is vibrate, right? And then the air inside is getting the energy from the vibrate of the bottle.
So the bottle vibrate
Yes.
and
The air inside
send in the energy
yes, send the energy to the
through
air.
vibrations.
Yes.
Do you agree with him or agree with him?
Since sound is a mechanical wave, it transfers through particles of the substance. So I think when it goes out of the speakers, it goes into the air, then goes past through the glass, and then makes the air inside vibrate too. So it makes the bottle and the air vibrate.
How did you make the measurement, or how did you find out about the natural frequency of the bottle?
Natural frequency of the bottle. I blow the bottle.
So how about the theory part that you mentioned about the neck of the bottle? Did you ever use that equation?
I use, but when I do the experiment and then I see it has an error, and then I think I don't have enough time, and then I measure by the frequency meter.
So that means you're not actually using that equation anymore.
Yes.
Right. So then next time don't put it there if you're not using it. The next question is that the force, or in your table you mentioned about the torque.
Yes.
How did you make the measurement of the torque?
I look in the tracker, and then I know the frequency of the carousels, and then when I know the frequencies, and then that means I know omega, and I will know alpha, and then I can calculate the torque.
You know omega, and then you know alpha. How?
Oh, okay, sorry. I will know the torque equal I alpha, right? And then I will know alpha, and then I will know the I.
What is the I stand for?
Stand for 2mr square.
2mr square. So that means you treat the bottle as a mass, a point mass?
Yes.
Okay. So how long is your bottle?
How long is bottle? Bottle is about 20 centimeter.
I mean the width of the bottle.
The width.
The width.
The width.
Yeah. this side of the bottle.
On this side of the bottle,
Uh-huh.
3.5 centimeters.
Okay. So do you think his way of using the I at mr square, is that appropriate? Yes or no? Reviewer first. Did you even listen to when I asked him? So I asked him that how did he find out about the torque? And he said that he used torque equal to I alpha. And how did you calculate I?
I use 2 mr square.
2 mr square? Okay, are you with me so far? The torque equal to I alpha, and he calculate I using 2 mr square. So do you think that equation is good enough to calculate the I, the moment of inertia? Yes or no? Come on. We don't have all day. Okay, opponent first. Give viewer some time.
I think no,
Why?
because it depends on the shape of the bottle, and he didn't tell about the shape of the bottle, so I don't think that this will work to calculate the
What did I stand for?
initial in moment of inertia.
Okay, reviewer, ready to answer? Yes or no?
I say yes or yes.
Yes, so you agree with him that mr square is okay to calculate the moment of inertia of the bottle in this problem?
No.
So you agree or not agree with him?
I don't agree.
You don't agree? Why?
I think there are other factors other than this equation.
Okay.